Hello everyone, my name is Shambhavi. Hope you all are doing well. So as we already discussed about the mean of squares and sum of the squares, all the things we are already familiar with, right? So now I'll be discussing about one of the very important topics today, and that is basically the calculation of sum of squares, the calculation of sum of squares and mean squares and mean square. Okay, so this is what we are going to discuss up. So we'll be seeing that how we'll be doing out the calculation for the sum of squares and even for the mean of squares. So what's the procedure that we need to follow? All those things we'll be seeing up here, right? Now I'll even be denoting out some different terms as well, so as to remember out the notations and what do they actually mean. That as well I'll be doing throughout. Okay, great. So here we have the first one, that is the k, that's the small k. So that is basically what means that out. So that is the, okay, that's not the different, it's the number. Yeah, so it is the number of, it is a number of different, it is a number of different groups. It is a number of different groups, right? So this is what is the calculation of sum of squares and the mean square. So k is basically one of the terms that we are having, and it is a number of different groups, right? Now moving towards the next point, we are having n of j here. Okay, what is that? So that is the size, it is the size of the, it is the size of the jth group. So it is the size of the jth group. So whenever you see out a notation written like n and in the denominator j, so you could understand that, okay, this is the size of the jth group, right? Now let me come down to the next third point, and now here what we have s of j. Okay, we have the next value, the very next value, that is s of j. What is that actually meaning? So that means the sum of the values, it means the sum of the values in the jth group. So when we talk about n of j, so it means the size of the jth group. Okay, and when we talk about s of j, so it means the sum of the values in the jth group. Fine. Next, moving towards the number 4. So number 4, we are having small n. What is that? So that is the total number of, it is the total number of all the values total number of all the values combined. Okay, so what is the small n? Small n is basically the total number of all the values combined. Fine. So even we could just as well say out it is a total sample size, that is sigma of n of j. Okay, right. Let's come down here. Next we are having number 5th, and that's the x, small x, that is equal to one value. Okay, one value, that is sigma, and here goes the x, that is equal to sigma, and here goes s of j. Okay, yes, this is what it is used for. So x is equal to one value, sigma x is equal to sigma s of j. Fine. Next we are having about the sum of, next we are having the sum of squares of all values, sum of squares of all values from, sum of squares of all values from every group combined. So yes, next we are having sum of squares of all values from every group combined, and what's that? That's sigma of, and here we go with the x square. So that's the sigma of x square, right? Now moving towards the point number 7. So next we are having that between group variability. So I will just write that as well. It's between group variability. So here goes the variability. It means what is that? It is the SS total. Okay, And what's the formula for that? S is total. So the formula for that is sigma of x squared minus, we have the sigma of sigma x whole square divided by n. Okay, one sec. Okay, that's a too much mess up right here, right? So let me just go down, get out some space for me to write out. Fine. So the formula which we are having for this particular is sigma x square. That sigma x square minus, in the bracket we have sigma x, into the bracket above we have a square, divided by n. Yes. Now this is the formula which we have for the between group variability. Okay. Sigma x square minus sigma x whole square divided by n. Okay. Next we are having the number 8. So the number 8 we are having here, that is the total sum of squares. Total sum of squares, right? So onto this particular total sum of squares, so we have total sigma x square minus, we have sigma x whole square divided by n. Okay, so this is the total sum of formula for the total sum of squares which we are having here. Then now we have the explained variation, so it goes explained variation. Now that we have a sum of squares representing REPRESCN like this, right? So sum of squares representing the variation among the different samples among the different samples, right? So that's completely the explained variation samples, and we could say that as S is between. S's, and downside we have like this between, and that is equal to S is between, that is equal to, let me get down from here so that I could get out of some space for writing. S is between, that is equal to, I would write it out here. So its sigma bracket goes on like this. So we have I would just write out Sj whole square divided by n of j, bracket closed like this, subtracted, then we have sigma s of j bracket whole square divided by n. Okay, so yeah, right, hope you are very much clear with this particular thing as well, whatever I had just written out at this particular place. Now fine, so explained variation already done. What about the unexplained variation? Okay, the number which I had mentioned above was number 9. Okay, right here. Okay, now it goes to number 10 here. That's the unexplained. It's the unexplained variation. Okay, it's the unexplained variation. Now, what is that actually unexplained variation? So it is a sum of squares. It is a sum of squares. It is a sum of squares representing. It is the sum of squares represent PR. Okay, that is REP representing. Okay, it is sum of squares representing variation. Representing variation within the samples. Representing variation within samples due to chance. Okay, so unexplained variation is basically the sum of squares representing variation within the samples due to chance. So what's the value for that? So it is SS width. Sorry, it's not width, it's within. 1 second. So it is SS within is equal to SS total and minus SS between. Right? So yeah, this is done. Now, right. So here we have many. We have some more things as well to be noted down. But right here, I'm just gonna stop up at this particular place only. for this particular video. So we had seen about the different ways for the calculation of sum of squares and the mean square. So these were the different ways that we have seen right here. Right, so hope you got out the idea very clearly regarding this particular thing, that how we will be able to do out all of these particular things. Right, so this is all for this video. Till then, thank you and take care.